Okay, good afternoon. Tough session, right? Right after lunch? I'll promise to keep you guys awake, definitely. And have a lot of content to cover, a lot of content to cover. I have about a good 125, 30 slides. So let's see. So my name is Sujit Ghosh. I'm a lead for the technical marketing engineers for mobility wireless in the wireless business unit in San Jose. I have been in Cisco for almost 19 years. Out of that, few years in TAC in San Jose, and then bailed out of there and moved to the business unit. So I've been doing wireless for a while. So definitely welcome to Cisco Live. And today, we're going to talk about wireless LAN controller architecture. How many of you have controllers already? Very good. How many of you have 9800 Catalyst controllers, Catalyst 9800? Oh, 1, 2, nice, 3, 4, got it, got it. So today I'm going to focus a bit on both of them. The 98, there are dedicated sessions for 9800. Probably you have seen some of them yesterday, and there is one more tomorrow afternoon. You can go for that. And what I'm going to focus on is the interaction between the two. What do you need to do to make sure that they talk to each other? Okay? That's what I'm going to focus on. I'm going to focus on software releases, two software releases, 8.5 and 8.8. How many of you have 8.5? Good. And 8.8? Only 2, 3 brave souls. No, I'm just kidding. No, definitely. I'll talk about those in detail, why you need 8.5 and why you need 8.8. I'm going to touch a little on DNSE, but probably you know all about DNSE, you've heard about DNSE, you've seen the demos of DNSE. But DNSE assurance and automation will not work if you don't have the right controller and right software. And that includes your software, which is running on the controllers, APs. Why? I'm going to explain those in detail, okay? So that's my goal for today. So that's the agenda for today. I'm going to spend a good amount of time in the second half of the presentation. Probably you have seen these slides thousands of times. It's all part of the intent-based networking. And it starts, obviously, with the hardware, which is the routers, switches, and your access points and controllers, which is feeding all the data back to DNS Center. What I'm going to focus mostly today is in this area. I'll touch, as I said, a little on DNS Center, because it will bring some ideas into you, what software you're going to use. Building blocks, quickly. It all starts, in my opinion, with the access points. It all starts with what type of access points you have, what do you want to buy. High density, becoming popular. Probably you have noticed over here, the main Cisco Live SSID is only running on 5 gig. We don't have a 2.4 SSID. We do have a legacy SSID, but the main SSID is on 5 gig. That means days has come now that you can survive without 2.4. Think about it. Think about it in your environment. Even if you keep 2.4, keep it for your IoT devices, for certain devices, or maybe sometimes for your guest network, because you don't know what type of devices are coming into your guest network. So keep the 2.4 for your guest. But if you know about your employees, time has come to move toward 5 gig. I know various implementations, including a company started with Face, whatever. They have completely moved to 5 gig. There is no 2.4 in the environment at all. So that day has come. So these access points are now built for those type of deployments, for dual 5 gig deployment. Intelligent capture, a very important functionality of these access points. And in future, all the access points which are going to come, they will have this functionality built into it. It helps you in capturing raw packets if there is an anomaly in your system. That means it's always the problem is with your boss's phone, right? Or your laptop. And they keep on coming back. I was in this room yesterday, and I couldn't connect to the network, and I couldn't do a WebEx call. And you don't know what happened over there. So with the help of this intelligent capture, hopefully we'll be able to capture those packets saying that what happened exactly at that time, why your boss's phone at that time couldn't connect to the network. So that's where we are going with it. And finally, we have been doing this for a while. Clean air, high-density deployment, all of this is built into the controllers and access points. So moving forward, pretty much all our APs are going to have more than radios, 2 radios on it. 2.45 is a given, and we are adding always a 3rd radio, as you can see over here, which is dedicated for performance monitoring and security monitoring also. So you will see that moving forward, all our APs are going to have 3 radios built into it, 3 dedicated CPUs, and memory on it also. So that introduces, I didn't talk about these APs till now in Europe, but you probably heard about it, is the 4800 series access point, the top-of-the-line access point which we have. It has everything, whatever you need, including Bluetooth as well as the hyperlocation. I don't know if you have seen the picture of this, and there's the same unit which I have over here. It's in the World of Solutions, in the DNA assurance demo. You can go and see this. This has everything, whatever you can think of from a radio technology. It has the hyperlocation antenna built into it. It has the Bluetooth antenna built into it. It has the 3rd radio for intelligent capture, as well as for monitoring of your network, for monitoring of your security events. We have deployed these APs over here also in a certain area, so not on these rooms, but certain areas. Keep in mind, these APs do not have external antennas, and there's no plan to have external antennas on it. So this AP will not be used in a deployment like this. It is used where you can put the APs like that for your normal, regular deployments with hyperlocation and less than 3 meters of accuracy, etc. Okay? So this AP will never have an external antenna, because I'm getting this question again and again everywhere. So this was the AP which we had, or the hyperlocation antenna we had on 3700 AP. So basically, we have taken the same antenna and built it over here, which is built into the AP itself. Okay? So that's where we are with our top of line. These are the smaller APs which we have. These have become very popular lately. The 1815 series access point, which has a version of it called the wall mount AP, which is basically used for dormitory deployments, hotel rooms, etc., where you have really targeted coverage requirements. Then this is our very low-end 11AC Wave 2 access points, the 30s and the 1830 and 1850, followed with the 2800, 3800, and 4800. 4800 is where we have the 4 embedded radios, 3 Wi-Fi, as well as 1 BLE radio for all your operations. Again, in order to accelerate the deployments and adoption of these 4800 access points, what we have done is commercially we have reduced the prices for the 4800 APs to be same as the 38 also. So take advantage of that, because you get a lot more with the 4800 APs, because you can get advantages of intelligent capture and other stuff, which I'll talk about as we move on. Okay? A quick recap of your 1800, the outdoor APs, the 1540s, the 1560, and the 1570. No changes here. We have been having this for a while. How many of you have seen this? This has become very popular. A lot of customers are looking at it. These are the small sensors. This is a device which is also almost like a client. So if you are managing multiple remote offices, and you're in the central office somewhere in London or somewhere in Spain itself, but you have office all over Europe or in Asia, and you do not have an administrator in every office, but you want to know how your network is behaving, this is one device you should look into it, where you can take one of these sensors, plug it inside your conference room, and these sensors can act like a client. So 7 o'clock in the morning, before your users are coming in, this device can act like a client, associate to the regular access points, and do some type of synthetic testing. Because every time a customer or your user tells you that wireless network is not working, it could be that your radius server is not working, your DHCP server is not working, or could be your default gateway is not working. So currently, we have about 12 synthetic tests, which is embedded into these devices, which can go in and do those tests for you. It's as if you are in a remote office and you are walking around with a laptop to find out if your network is up and running or not. So these are the sensors which is available now. You cannot get this working without DNS Center. Keep that in mind. You have to have DNS Center in order to make these sensors work. These sensors can be provisioned with the help of DNS Center only. But the good thing is, they don't take up any licenses in your controller. So if you have a controller with a 100 AP license, and you buy about 10 of this, and you do distribute in your network, they don't take up any license on your controller. But you need to have DNS Center in order to take the feed from these sensors and tell you that in this office, what is the performance? In the second office, what is your performance? The idea over here is, if you are running out of DHCP scope, if your radius server is not working, if your default gateway is down, these sensors will be able to pick that information and send it back to DNS Center so that you know something is going on in that office, and you can take some proactive action. That's where we are going with it. So it's a small piece of hardware. I have those in the World of Solutions. Go take a look at it. And we have deployed this over here also. So in this venue, there are, in certain locations, we have deployed these sensors, which are constantly doing the. So if you go to the NOC, they will be able to show you a DNS Center demo where we have some of these sensors in action also. Okay? So this sensor functionality is also available on the other access points also. So you can all buy these dedicated sensors, or if you have some sensors or some old access points lying around, you have some extra ones, you can convert now one of these APs to act like a sensor also. That means it'll take one of those APs from there, convert it into a sensor, let it associate to those APs, do those testing, give you all the results, and turn it back to a regular AP after that. So that is possible on these access points, the 1800, the 2800, and the 3800, or you can use the dedicated sensor on it. Because what I'm hearing from every customer now is troubleshooting. Troubleshooting is top of mind. Wireless deployment has been done, no problem. RRM is taking care of radio and channel, but it's always the issue lands up to be on other devices, or like DHCP server, or your DNS server, or your radius server performance. How can we detect those? Okay? As far as controllers are concerned, there's nothing new over here. You have seen this probably for a long time, the 3504, the 5520, and the 8540. And we have the Flex Connect support on the VM as well as KVM. But I want to quickly introduce to you the new controllers. If you have not seen it, this is the 9800 Catalyst 9800 series controller. We launched this in November. It's holding up pretty good. We have quite a few deployments already worldwide, and we did an extensive beta on it also. So the 9880, this is the 80 gig controller, and this is the 40 gig controller, as well as we have the same software now can be run on an AWS instance anywhere in the world. And also, you can run it on GCP or Google Cloud. Currently, the Google Cloud is in trial or beta. We are in the final process of signing the agreement. And then you can run this on your Cat9K switches. So if you have a 9300 switch, you will be able to run the same software on it. But keep in mind, it works in the switches only in SDA mode. That means it will not be supported as the full-blown controller. It is only going to be supported in SDA mode in 9K switches. OK? Or some of the, I'm not going to go through all the details of it, but the key things we are focusing on this controller is support for encrypted traffic analysis and stealth watch integration. A lot of improvement have been done on HA in these new controllers with the help of the iOS XE platform support on it. With iOS XE support, we are making a lot of enhancements on these platforms, as well as it's fully based on the open standards with netconf Yang and programmability. So the idea is whatever your information you're getting via SNMP, now on your AirOS controller, you will be able to get all the information for your configuration and as well as all the monitoring data via netconf Yang. That's where we are going with these new controllers. OK? What all APs are supported? Pretty much all your 11AC Wave 1 and Wave 2 APs are supported with these new controllers, as well as we have support for all the modes of it, like all the AP modes, as well as the like local mode, Flex Connect, and monitoring mode. So pretty much we have support for full functionalities with the new controllers. This is how the new controller looks like. This is just for your reference. If you want to see one of these in action, it's in World of Solutions also. A thing a lot of customers have been asking about, how does it compare with the AirOS controllers? Just keep this picture handy. It's much more smaller than the 8540 controllers were all based on UCS platforms, but these are all designed from scratch. So we could significantly reduce the size of this, because a lot of customers came back and said that those controllers are too big. These controllers or these UCS platforms were usually designed for data center racks. It becomes difficult to do the installation in a normal enterprise, I would say, data center. So keep in mind, we significantly reduced the size of that. This is the only controller which has support for up to 100 gigs of uplink. So we will support from day one modules which can support 10 into 10 gig ports, or you can go all the way to 100 gig. So those are already available, so that if you have an upstream switch where you just have only 10 gig ports or you have a 100 gig port, you will be able to take advantage of those interfaces also. A quick comparison of this with the 8540 controllers. I'll not go through all the numbers, but I want to point out to one item over here is this last one with the AVC flows. So we have done significant improvement on the software as well as on the hardware to support high number of AVC flows. If you know currently on the 8540 controllers, if it is fully loaded, you can see a little of a performance degradation on it. But with these controllers, with the increased number of flows, we will be able to take care of that issues we are seeing on it. So you will be able to see full line rate when the controller is fully loaded with 2,000 access points, 6,000 access points, and 64,000 clients on it. Okay? This is the smaller brother or the younger brother of this, which is the 9840 with 4 gig ports on it. And if you compare this with the existing 5508 controller and the 5520 controller, it's much smaller than that. So now we can fit this into a regular rack, which is in your enterprises instead of being in your data center. And this is an important point because a lot of customers came back to us. Similarly, a significant increase on the AVC flows on the 9840 also in order to support those high-density deployments. We do support for this in the cloud, as I talked about, GCP, as well as when you are supporting this in AWS or in, we do support all of these APs when they are in the cloud or public cloud in flex mode only. We are not sending all the traffic from the client to your controller. We are dropping the traffic locally on the access point itself. But if you are deploying the same software in your KVM or VMware environment, we do have support for all of it, centralized, Flex Connect, as well as Fabric. So keep that in mind. If you're doing a private deployment or private cloud deployment, we do have support for all functionalities on it. But if you're doing it on a public cloud, it doesn't make sense to send all your traffic all the way to the cloud. We will be dropping the traffic off locally. So that's what we mean over here by, oh, sorry. God. With the help of Flex Connect local switching. That's the difference between the two deployments of cloud. So private cloud will support all functionalities, all modes, including HA. So we have now support for full HA when you are doing a deployment of KVM or on a VM ESXi, we will be able to do full HA. And I'll cover that in a couple of slides down. OK? Any questions till now? OK, so let's now talk about mobility and how we. So this is the full picture where you have your APs, controllers, and you have your management platform. It could be Cisco Prime or DNSE. And you have your mobility service engine, CMX, or the new name for it is called DNS Spaces. So now, at the bottom of it, everything is CAPWAP. So we moved out of Ethernet over IP, and everything is CAPWAP. CAPWAP is used between access points and controllers. And moving forward, we are going to use CAPWAP to encrypt the traffic between controllers also. So let's talk about that. The CAPWAP state machine, it's important to understand every time an access point boots up, goes through this process of discovery, join, download the config, and goes to a run state. But if the software version is different, it downloads the software, goes through a reset, and comes back. Keep this state machine in mind. I'll talk about this later. But mobility is key. We know that. Mobility is required if you are doing a deployment for wireless on it. For that, we introduced this concept of mobility group. So we have, say, 3 controllers on it. You put them as part of one single mobility group. We form what we call as Ethernet over IP tunnel between these 3 controllers, and we exchange the database among all of them. For example, a deployment over here in Cisco Live, we have about, they told me about 3 sets of controllers, 3 sets of 5520 controllers and 8540 controllers, but they are all part of one mobility group. So as a result, when you are going from this hall 7 and 8 all the way to hall 5 or in the keynote area, all of them are part of one mobility group. Okay, so we peaked today to about 15,000 clients. In the afternoon, last I checked, we had about 15,000 clients on the network as of today. So this is how it forms. So you can put about 24 controllers in one mobility group, and you can roam between 3 mobility groups. But the key over here is what we call as the software version support. In this venue, as I said, we are using 4800 series access points also. For that, we needed a controller which is supporting 8.8. But the rest of the APs in the venue is all running on 8.5. So we have this main area. All our rooms are running 8.5 code, but there's a section on the other side which is running 8.8. But the key message over here is you can run two different software versions, and you can still roam between them. You can have two controllers as part of two different software versions, but you can add them as part of one mobility group. This is how we test it, and we are supporting it, and TAC will support it. So keep that in mind, because that is very important when you're designing your networks. But at the same time, if you are now buying these new 9800 Catalyst 9800 controllers, what do you need to do for roaming? So in this case, if you look at it, what I have over here is your existing 5520, 8540 controllers in your network. Now you decided to bring a new Catalyst 9800 controller, and you want to roam between these two networks. Maybe there are two different buildings or two different areas on it. So what you need to do is you need to make sure that this controller, which is your AirOS controller, needs to be upgraded to 8.8 MR1. If you upgrade it to the new controller image, you will be able to form what we call as a CAPWAP tunnel. So now, moving forward, in order to roam between controllers, we are not going to use Ethernet over IP. We are going to use CAPWAP. So with the upgrade of these controllers to 8.8 MR1, it will convert this tunnel between the two controllers as CAPWAP tunnels. So that is needed. Keep that in mind. If you have a new deployment coming up with Catalyst 9800 and you have an existing AirOS controller, if you want to roam between those two, you need to upgrade to 8.8 MR1. We're looking at an 8.5 code also, which will probably come out in a week or so, but wait for that. And then if you do that, you will be able to do seamless layer 3 roaming between the two controllers. Okay? Similarly, if you have an environment, you have upgraded one of the controllers in your network, but if you have other deployments also in your network, you don't need to upgrade these controllers at all. It's only the controller which is talking to the 9800 controller needs to be upgraded to 8.8. These controller, which is there in your network, can remain with the older code. Most important thing to understand in this slide is this controller, which is now upgraded to 8.8 MR1, is supporting CAPWAP on one hand with your new controller, and it is supporting Ethernet over IP with your older controller. That's what we have added as part of 8.8 code so that it can talk to your older controllers using Ethernet over IP, your new controllers using CAPWAP. Probably at one point of time, a year or two from now, you will turn off Ethernet over IP, and it will be all CAPWAP based. So between your controllers, you will enable only CAPWAP so that you have a standard method of exchanging all the mobility messages. Any questions on that? That's the reason I said that you have to go to 8.8 if you are doing a 9800 deployment and if you want to roam between the two controllers. If you are putting into a new location, you don't have to bother about this. No, that's not correct. For example, if you have a guest access deployment, how many of you have guest access deployments with Ethernet? Very good. So what we have done is, so if you have an AirOS 5520 controller in your network, which is doing termination of Ethernet over IP tunnels for your guest network, for example, over here, you can upgrade that controller to support 8.8 MR1. And if you have your older controllers, the 5520s, and all of them supporting Ethernet over IP, they will work as they have been. But if you bought your new 9800 series controller, they can now form this CAPWAP tunnel to your anchor controller also. And this was one of the key items I worked on from day one with engineering to make sure that you don't have to change every controller in your network when you are going towards the 9800 series controller. So that it fits into your existing network, you just have to make sure that the anchor controller is upgraded to an 8.8 so that you can run Ethernet over IP tunnels for your AirOS controllers and CAPWAP tunnels for your new controllers. And then at one point of time, if you want to, you can upgrade these guys also to 8.8 and convert them to use CAPWAP. So you can migrate to CAPWAP everywhere. But as of now, for example, if you have some APs which are connected over here, you cannot upgrade the controllers, fine. Leave it as it is. At one point of time, when you can upgrade these controllers to 8.8, you completely get rid of Ethernet over IP in your network and migrate everything to CAPWAP. That's where we are going towards. That's what we want to see in all your networks in next 2 to 3 years from now. Any questions on this? Clear? OK. Looks like. So that's on the infrastructure part of it. I'm going to quickly touch on DNA assurance, but what we have done on the controllers in order to. So the main idea for DNA assurance is visibility, a lot more visibility of the clients. That means what is going on with those clients from association to authentication till it's in the run state. That's what we are, and how we can tie it up with analytics coming from the devices, iOS analytics, with our partnership with Apple and other vendors coming in the future. And then the sensor tests, which we talked about. And finally, we are going there where we can tell you in advance that looks like your radius performance is going down. You pay attention to your radius server now. That's where we are going towards. So what we have done in the controllers with 8.5 code onwards is we implemented netconf and YANG telemetry models. Previously, we were using SNMP to send all data from the controllers to your prime, etc. But the problem with SNMP is it's getting slow. It's getting heavy. Imagine that you have a controller with about 1,000 access points, 6,000 clients connected to it. And your prime is trying to get all the data from the controller for every client. It makes an SNMP query. The controller sends all 6,000 clients' information back to the controller, back to SNMP server, which is your prime. It takes a lot of time. And it is putting a lot of pressure on the controllers also. So it was affecting the performance of the controllers. The problem with that is when you have 6,000 clients connected to one controller, all of those clients are not roaming at the same time. Maybe only 10% or 20% of the clients are roaming. So the information about those clients are pretty much static. Their IP address is not changing. Their DHCP value is the same. The RSSI values are same. It's not changing. So why do you want the data every 30 seconds from the controller? So with the help of this netconf YANG models, which we have implemented, what we call as network telemetry, now you can make query saying that I want to get all the client information whose RSSI value has changed in last 20 seconds or 10 seconds or 30 seconds. Rest of it, I don't care because the data is same. So all of this is possible only when we build this new netconf YANG models on top of our existing infrastructure to do specific query, say that I want data only for clients for last 10 seconds whose RSSI value has changed. So you can go into a lot of these models and see that. So periodic data, you can say every 2 minutes, I want full data from the controller. But for every 30 seconds, we only want data whose value has changed only. Okay? So that's what the first thing we are. Then we have the structured data, which I talked about, where you can now make queries into various levels of it. It helps in scalability so that you don't have to pull that information every time. And the main goal is to reduce the CPU load on the controllers. So that's what we have done with the help of a functionality called streaming telemetry. So with the help of migrating your controllers via software to 8.5 and anything beyond, that's where we have implemented these Yang data models. And with the help of those data models, using the netconf and restconf, and we will be now able to export all your data information. So if you're using DNS Center or DNS Assurance, we don't use SNMP anymore to get your client data. We are using those netconf Yang models to get all those data from the controllers. That's where we are going towards. Even on the 9800 series Catalyst controllers, we have implemented that from scratch. So you will be only using only netconf Yang models to get all your transactional data from the controllers. Okay? DNS Center includes automation and assurance. We do have support for all of them in your SDA mode, your centralized mode, Flex Connect, as well as Mobility Express. So now DNS Center can support all modes of it. And in all mode, we have implemented those netconf Yang models so that we can get those streaming telemetry data from the controllers. Okay? I'll have 2-3 slides to talk to you about the key use cases. And I'm going to talk about this not from a DNS Center perspective, but from the controller, what we are doing to get that data. First thing is real-time analytics. That means as the problem is happening, as your clients are connected to your network, I want to get that live data from your controller. So real-time client stats. Then you have your sensors, which we talked about. And then you have your intelligent capture. That means using the third radio on those APs, like the 4800 APs, we can constantly monitor your network. I'm talking about a use case where you are very familiar with that some clients will come back and say that I simply cannot connect to the network. Every time I connect to the network, something is going wrong. So you can mark that MAC address of that client as a VIP client. And you can say that every time this client connects to the network, I'm going to monitor it. And if the client is failing, I'm going to capture some packets for it, the raw packets between the client and the access point, so that you can do some analysis, so that you can open that up in your Wireshark. And the main idea, again, you don't have to send an engineer at site in order to do that troubleshooting. You will be able to do that remotely from your data center itself or from your NOC itself. So that's what we are going towards. So first action, what we will be able to see on the DNS Center is a general overview of your client health. So you will be able to see what % of your clients are in good connectivity, fair connectivity, and what amount is failing because of AAA, because of DHCP, and it's failing on disassociation or association. So that's the very first information you will be able to get from DNS Center. But all of this is coming from your controllers using those netconf Yang models, okay, and streaming telemetry, which we have enabled. Then you will be able to see real time why your client is failing. So if you have a deployment with CMX, we'll be able to integrate between DNS Center and tell you that what is the approximate location of your client, why it is failing, and what was the performance we saw at that point of that network. Okay? Final is the intelligent capture, which is basically onboarding failures with in-service PCAPs. That means if your client is constantly failing in connecting to your network, maybe somebody has put the PSK key wrongly on the client device. It's constantly failing. You don't know what is going on. It will give you all those events. Plus, when it is failing, it will capture those packets so that you can do those analysis on it. So it tells you that, OK, it's authentication started, association started, client and it is authentication done or failure. So at this point, it tells you exactly what happened in your network. This is almost running a debug on your controller. Instead of running it on the controller, now you're capturing that in DNS Center. Okay? But the important thing to understand is we are not running actual debug. We're getting all this information via netconf and those Yang models. Finally, the use case, what we are focusing on poor experience. That means a dashboard saying that where is your clients, what type of APs you have in your network, what are your top-end APs, and top-end high-performance interfering APs. If you're used to Prime, we get this information in Prime also, but this is also included on DNS Center. This is an important use case I've been working from day one, and you have heard this many times. It's always in your boss's phone and laptop, right? I was in this conference room yesterday at 3 o'clock, and the wireless network was not working. And you guys, as administrators of the networks and designers, you have no clue what was going on. So what we have done is we have collected those information from the controllers, and we have created what we call a 360 view with a time travel. That means it will tell you up to 7 days back what was the client performance at that particular time, and you can slide on it, which device we are talking about, what type of OS it was running, what was the IP address, what SSID it was connected to, which AP it was connected to, and what was the client health, and why that user was failing. Maybe it was taking too much time on re-authentication. Something happened in the network. It was something, your radius server was down. As a result, from that location, they could not connect. Currently, you have no clue. If your boss is coming to your office next day and telling you that I was failing, you have no way to tell that what was happening yesterday at 3 o'clock at this particular conference room. So with the help of those netconf Yang models, with streaming telemetry, we are collecting all the data and storing it in DNSE so that you can roll back time and find out exactly what the client was. So this is something I worked for a long time. And then finally, on-demand packet captures to tell you exactly what was happening on that particular client device. And that's, again, for your troubleshooting purposes. Finally, application performance. That means you have a good connectivity, but somehow you couldn't make that Jabber call. Somehow you couldn't make that link call. So we want to find out what was going on. For example, at that point of time, you can define up to 10 applications that you want to monitor, which is important for you, so that you know how that client was behaving at that point of time and what type of applications are. So you will be able to see via App 360 and go back yesterday and say that, OK, I see that the device was connected properly, but there was some issue with the Jabber client or the Jabber performance, so that when your boss comes back and says that, I couldn't make the phone call yesterday, you at least know that was it a network problem? Was it a wireless problem? Or it was an application performance issue, so that you can pinpoint it and tell that what was going on in your network. And obviously, you have the option now that those sensors can simulate some application performance also. That means those sensors can do a FTP transfer, or it can do a ping, an IPerf performance, or it can go to your and do a speed test and tell you how your network is behaving. That means if you're an office in London and you are sitting over here in Barcelona and you don't have an administrator, you can take those sensor and enable those speed test function in the sensor itself so that it can go to the nearest speed test center and tell you how is your network behaving. So that's another application performance. And in future, you will see that those sensors will be able to simulate a Jabber call as well as a Microsoft Link call to tell you that if your network is ready for those performances or not. So we're doing a lot of stuff on the network itself, on the controllers, in order to enable those functionalities while the client is connected, or roll back time and tell you yesterday 3 o'clock what was happening, as well as you have those sensors which can simulate your applications. Currently, we have about 7 or 8 applications which can be simulated, like FTP, IPerf, as well as speed test. And more applications is going to be added as we move on into this system. So that's what we are talking about, the third use case on the client experience part of it. Any questions till now?
Is there any code requirements for all that functionality?
Very good question. Is there any code requirements for all these functionalities? I'll be very clear. If you want basic client information, how is the client behaving, all of that, you can run 8.5 code, okay? Any versions of 8.5 code. The moment you go towards intelligent capture, sensors, etc., I would recommend 8.8. Especially the 4800 AP, using the third radio, I would highly recommend using the 8.8 maintenance release code, which is already on CCO for all of that. But basic connectivity, basic client information, Client 360, you can get it with 8.5 code. But for all intelligent capture, sensor, application performance, everything is all 8.8 MR1. OK? Had a question? Very good question. Is there a way to capture the MOS scores? That's coming. So when we add the Jabber client as well as the Microsoft Link client on it, so we will be able to simulate that call and give you the MOS score. That's the first thing I asked on it. The moment that client information is there, I think we are in the process of signing a contract with a third party who will give us those clients, which we can put it onto those devices. So as soon as we put that, the MOS score is a must. Without that, it doesn't make sense. There was a question at the back somewhere. No? OK. So I'm going to quickly touch on a small topic, is Mobility Express. And I'm seeing this becoming very popular in many, many parts of the world. So if you have a really small office deployment, and you don't have the budget to buy a controller, and it happens. We introduced this Mobility Express about a year or two back, and it's getting very good momentum these days. So you can have a small office with 3, 4, 5 access points, and you can take one of our existing access points and convert that into a controller itself. So that's what we talk about as a Mobility Express. So the controller software, which is available on a hardware, will now be available on the AP itself. So one of the APs, it could be any one of the APs, can be converted to a Mobility Express AP and make other APs join that particular access point. So you have a small software-defined controller based on those APs itself. That's becoming very popular, especially for your small deployments. It can go up to 100 APs and 2,000 clients. And also, it's very easy to deploy. It has a new UI on it to make it very simple. But there's an advanced UI also, but you can do that. It has support for AVC and CMX. It has support for all the RF innovations we have done over a period of time. For example, RF profiles, et cetera. And also HDX, Clean Air, Apple Fastlane. We do have functions for guest access, as well as all of this can be managed by DNS Center, as well as Prime. So Mobility Express is nothing but a software version of the controller on an AP. So you can take any of our APs now and convert that into a Mobility Express AP, and it can have other APs joining those controllers. We added a lot of software functionalities on Mobility Express so that we have full feature parity between the controllers, existing hardware controllers, and this Mobility Express. I just included this for your reference. I'm not going to go through this here. But this is how it works. So you can take our smallest AP and convert that to a Mobility Express. It can support 50 other APs and scale up to 1,000 clients. But at the same time, you can use a 3800 controller or a 4800 series AP also and make that a Mobility Express. It's just a software conversion, and make that as a controller and have other 99 access points join it. So this is becoming very popular, especially for really small branch offices where you don't want to put a physical controller. You're not going to deploy a Flex Connect solution, but you just need to have the same controller functionality, convert one of the APs to a Mobility Express controller, and have the other APs join it, and you pretty much get access to all the features and functionality on it. Okay? So that's something that's becoming popular. A lot of customers are looking into it for some of the branch office deployments. Any questions till now? What about license? That's the best part. Mobility Express doesn't require any license. So you don't have a special license, nothing for it. You just, as long as you have an AP, you download the Mobility Express software from CCO, and you're good to go. Any other question? Yeah.
On the previous topic, for all the client insight you just showed on the previous topic, is it required to have DNA Center, or if you have a single controller deployment, is it possible to see the same information?
So all the information which I showed before, not Mobility Express with all assurance, basically, for that you need a DNS Center. So in that case, because all the data, what we have enabled via telemetry is all fed to DNS Center. But in case of the Catalyst 9800 controllers, using the netconf YANG models, you can take the data and put it on a Kibana software if you have with Logstash running on it. So you will be able to take the data from the controllers for Catalyst 9800 and put it onto Kibana. But for the AirOS controllers, in order to take all the netconf YANG data, you need DNS Center. OK? So I'm going to switch gears. We talked about the infrastructure. We talked about all the deployment models. Let's little talk about all the improvements we have done between multiple software releases, focusing on RF optimization, HA, and AVC on it. Okay? HA, it's given. HA is available in all software releases. We do have support for AP SSO and client SSO in all our releases. So controller redundancy, this is the simplest form of redundancy we have, where you have one backup controller and you have multiple controllers in your network. If you lose one of these controllers, all the APs fall back to your backup controller. Simplest form of redundancy which we have supported. My best practices recommendation is if you are doing that N+1 redundancy, make sure that you play around with some of your timers, this AP heartbeat timer. That means how fast you want the APs to detect that your controller is gone. I'm going to fall back to the backup controller. Okay? Something to keep in mind. You can stay with the default timers, but you can always change them so that it is constantly checking that your controller is available or not, or it's going to fall back to your backup controller. That's for N+1. But if you are doing a N/N deployment, that means you have two hardware controllers, you connected them back to back, and you have full sync of configuration as well as database, then you get full SSO on it. How it works, you have two controllers, they're connected back to back, and they form what we call as an SSO pair. So one of them is active, other is standby. Via the redundancy link, the AP joins the primary controller, client associates, all your traffic is passing through the active controller. But if you lose the primary controller, we notify the peer saying that your primary controller is down. The second controller or the backup controller sends an ARP, gratuitous ARP, updating the switch, saying that start sending all the association traffic as well as the client association traffic through this particular hardware controller. This is what we call as AP SSO and client SSO. So if you have two boxes, they're connected back to back, and we sync the database between the two. As a result, you have zero downtime in your network. You might lose a ping, but now these days I've seen that you don't lose even a ping response from your client in this case. It can be between two different pairs of controllers. For example, it has to be like two 5520s or two 8540 controller. You can have this on your 3504 controller. You can put these two controllers back to back in a single tray and have an HA pair and scale up to 150 APs. Similarly, with the Catalyst 9800 controllers, we do have the same functionality. You can connect two 9840 as well back to back with the redundancy port, or you can take a 9880 and connect it with a redundancy port. But the difference with this new controllers is this redundancy port can support a fiber connection also. In the older controllers, we didn't have support for fiber. In the new controllers, we have support for fiber for the redundancy port. So as a result, if you have two buildings in your campus and they're connected via fiber, now you can have these two controllers as part of two different data centers. But you have to have a layer 2 connectivity between the two in order to form that redundancy. But that was a request we got from a lot of customers to support that redundancy port over fiber so that you can extend them between two different data centers. Before that, we used to recommend put both the controllers as part of one data center, connect them back to back. But now, with the new controllers, since you have support for fiber ports on the 9800 series controller, you can put them onto two different. Just a small difference, but a lot of customers have been asking for it for a while. So that's the SFP, gigabit SFP port, or redundancy port, which we have. With the 9800 series controllers, the virtual version of it, which can run on a VM or on a KVM environment, we have now support for similar full HA. If you use AirOS controllers now, and if you use the virtual form factor of it, we do not have support for any HA. But with the 9800 series controller, we have now full support on HA. So you can take two instances of virtual controllers in a single box or in two different UCS platforms, and you can have support for full HA on it. So you will be able to sync the database between two virtual instances. It can be in part of one box, as I said, or two different boxes, so they can be synced with the help of this HA interface. So now you get full redundancy using virtual controllers with the Catalyst 9800. That's another main difference. As a result, we are seeing customers going towards the virtual environment a lot because they can now build up multiple instances of it and have full HA as well as AP and client SSO between the two instances of VM on it. Question?
Does it also work between the physical and the virtual?
No. So the question was, can you do a combination between a physical and a virtual? No. When you are doing HA, it has to be the exact same pair. That's the first check which we do when we bring up an HA pair. So it has to be either two physicals or two virtuals on it. Okay? You cannot mix and match. And they have to be exact same platforms. You have to have a 5520 and another 5520 to do a pairing. You cannot use a 5520 and an 8540 for your pairing of HA. Question? So what about the mode of the APs? You will be able to support all modes of the APs on the virtual controller. So with the new 9800 series controllers, what we have done is we have enabled full central switching. So it's almost having the same. But it depends on the throughput of the box which you are installing your VM instance. So you can go up to 2.5 gig of throughput onto the virtual instances. Okay? So what do we test in our labs? Question. Is there any HA in Mobility Express model? Yes. So in case of Mobility Express, we form a VRRP tunnel between two Mobility Express. So what we do is we have, say, one AP acting like a controller, and we will select another AP automatically with the highest MAC address in your environment and convert that as a backup controller, and we do the selection based on VRRP on it. So you have HA built into it. And if this, and we look into the MAC address, we look into the what type of AP it is. We select the AP with the highest performance, memory, and all to make it as a backup controller and use VRRP to designate. So if you lose the main AP, your configuration is synced with the backup, and you will be able to keep the traffic alive. Okay? Good question. So in this case, we have the 5520 controllers, which can be connected to a VSS pair, or you can support this in a non-VSS environment also. So you can have a few of the ports connected over here and a few ports onto the same switch, or you can split it up between a VSS pair. And this is always we test it in our environment. So every software release, so if you lose your one of the chassis in the VSS pair, all your connection goes through the second. Configuration of this is very simple on the 5520, 8540 controller, as long as you have two hardware which are exactly the same. The biggest advantage is you don't have to put a license on the backup controller. You just buy the hardware for your backup controller. When you lose your primary controller, all your license gets transferred to your backup controller. All you're buying is your backup controller, which is only the hardware appliance for your backup controller. Question?
Why would you prefer a layer 2 link for your RP port rather than directly connected?
What would you prefer for the RP port instead of directly connected? I would highly recommend use the RP port to be connected all the time, because we use that RP port for all the transaction of the keep alives, as well as when you are doing upgrades and downgrades, and all of that is going through.
I meant running it through the switches rather than actually just using a cable.
You can use both of them. You can use both of them. I would prefer to use them directly, but if they're far away and you cannot connect them, then you can go directly on it. But I would prefer using them through the switches. Prefer directly. If you have to use through a switch, you can. And just to avoid that situation, in the 9800 series, we added the fiber so that you can extend it over a kilometer or 2 kilometers in your network, depending on your fiber connectivity. Okay? But prefer always direct connect. Okay? Yeah.
Mm-hmm.
Yep.
And now customers want to expand the network.
Yep.
And want to spread
Okay?
Is there a possibility to, okay, it is not possible to form redundancy?
Yep.
N plus 1 is
Yep.
possible?
N plus 1. So the question is, his customer has an existing 8540 controllers, and now they are using a 9800 series controller for their other part. Can we do an N plus 1? Yes, absolutely, you can do an N plus 1. Moving forward, what we are going to do is the AP software in the 5508 controller as well as on your 9800 controller will be synced up. So as a result, if the AP falls from a 55 or an 8540 controller to your 9800, it doesn't have to download the software anymore. It just joins your other controller, downloads the configuration, and you will be good to go. So you can have a N plus 1 in a scenario where if you lose your APs on the 8540, it can fall back to your Catalyst 9800 and just join the controller and start operating.
Is it possible to management from a single platform of the both?
Yes. So if you are using Prime right now, so you can upgrade to Prime 3.5, where we do have support for your AROS controllers as well as the iOS controllers also. So if you're using, so you will be able to create templates and push configurations on both of them so that they are in sync, and also monitoring can be. So you have to upgrade to Prime 3.5. Okay? What all is synced? What is not synced in SSO? So when we are doing this pairing, what is not synced in SSO? Nothing. Everything is synced between the two, including configuration, software version, client information, pretty much everything is synced between. So if you literally take certificates, but I thought we fixed the certificates in this thing. The certificates are synced between the Prime, because if you replace them, there was an issue initially in 8.3 or 8.0 code, but I thought in 8.5 we moved and we synced the certificates also. I may be wrong, but I know about that issue way back in 8.0 and 8.1 or 8.3. We had the certificate issues, especially when you are upgrading, etc. There were no, or if you're replacing one of the pairs of the HA pair, there was an issue on that. But I'll definitely check on it. That's a good. It's there in 8.5 still? OK. That's a good point. I will check. I will check with Javier probably. But other than that, I'm not aware of anything which is not synced between the two devices. Let's quickly touch on RF or the AP groups. I think pretty much everybody is using AP groups. Yes? No? OK, good. AP groups is becoming very popular, especially when you are deploying a large network. For example, if you have 3 buildings and you have all of them as part of one single VLAN, but every Christmas, students are coming back with new toys, and here you go. Your IP address requirement is increasing by 10%, 20% over here. So you cannot keep on increasing the size of your VLAN. So as a result, what we are suggesting is splitting your network into multiple AP groups and associating them into multiple VLANs. So you can use VLAN 60 for this AP group is VLAN 70, and this guy is on VLAN 80. As a result, you can now slice your network into multiple smaller networks so that you can control your IP address assignments on it. I asked the network team before coming here, we are using 30 AP groups in this venue. So we have created this small network so that we could keep the broadcast storm in a smaller domain. So for large areas like this, we created about 30 AP groups so that if you are in this area, you are part of this AP group. When you go to, say, Hall 7 or you go to Hall 5, we are part of different AP groups. So we have almost created 30 AP groups so that you can have, because what we do is we monitor what is the utilization of your of the DHCP scope in each and every VLAN. So as a result, if we see there is more IP address needed tomorrow when we go to a peak network, we can add another VLAN over here, say VLAN 61, and do a round-robin assignment of IP address, so you don't have to redo your VLAN on it. So that's the reason specifically I asked everybody before coming, they are using 30 AP groups among 3 sets of controllers on it, okay? Then the configuration of it is very simple. 3 AP groups, same SSID, mapped to VLAN 60, 70, and 80. That's it. Along with AP groups, obviously, we are associating them with RF profiles. Very important. Please take a look at it, because every RF network is different, so that you can tweak it as per your requirement. This is an example from a keynote configuration which we have done in Cisco Live some time back, where I made sure that we took down all the old or some of the data rates. We tweak the data rates, et cetera, and create separate RF profiles for your environment, especially if you are doing a high-density deployment like this, where we have just 2 access points over here. We have 200 people connected, and I can guarantee you all of you have at least 2 devices on it. So this is a perfect HD or a high-density deployment. Use RF profiles so that you can turn off the low data rates, so that you can just deploy 5 gig only and play with several other configurations on it. But if you don't want to do this, we have done this configuration already for you in terms of templates. So you can say that if it's a typical density, and if you're doing it for data or data plus voice, we will do all those configuration changes for you automatically. So we have about 6 templates on it for high density, low density, and a typical for 2.4 as well as 5, where we have basically taken all our best practices and configured them for you. So now we are constantly tweaking that. As a result, you can now say that if you're doing a high density deployment in your campus, just use a separate RF profile, use a separate AP group, and associate them with that RF profile, so that you say that this area is going to have a different RF characteristics compared to other. So again, over here in Cisco Live, we have 30 AP groups associated with almost 30 RF profiles, because every area is a different RF environment. They want to tweak the network for all of that environment. So this is what we have done finally. 3 buildings. Imagine hall 7, 8, and 5. 3 different VLANs, 3 different AP groups, 3 different RF profiles. So as a result, this building, every client over here gets an IP address from 60 or 61 in a round-robin fashion. Over here, 70, 71, 80, 81, and you have different RF profiles associated to it. Imagine this could be your keynote area, where it is really dense environment, or this could be your classrooms, or this could be World of Solutions, which is a different environment because it's open and you have multiple vendors on it who has brought in their own access points on top of it, right? It's like the worst environment in RF you can think of, because you have no control about what is going on in your network. So that's the reason that this is an example. Imagine this is your classroom. This is your sessions happening, or the keynote area, and this could be your World of Solutions. And that's what we are asking all our customers to move towards. Use AP groups, use VLAN pooling, along with RF profiles, so that you can segregate your network into multiple components, so that it becomes easy also for your troubleshooting purposes. Okay? On top of it, as I said, this is the new functionalities which we have on all the 11AC Wave 2 APs, where you can convert the APs via software to dual 5 gig. So by default, the APs come with 2.4 or 5. You can now convert this 2.5 radio to act like dual 5 gig. That's what we are doing over here. All these APs which you are seeing over here originally were supporting 2.4 and 5. we converted them to dual 5 gig so that now you have everywhere 5 gig radios and your clients are connected only on 5 gig. We might leave few APs to run on 2.4, but majority of it is now converted to especially important if you are doing a high-density deployment like this in a university, in a classroom where you have lots of devices coming in. I'm highly recommending moving towards this where you can convert these APs via software to dual 5 gig. That's called FRA. You can do it manually, or you can do it automatic. So the system will automatically decide which APs are going to be on 2.4, which one is going to be on 5. But if you don't want to do that, you can do it manually. Over here, we have done it manually. We converted all the APs to support into 2.4 or 5 gig. All right. Okay? So take a look at it. This is becoming very popular, and I'm highly recommending on it. Bandwidth. Are you going to use 20 megahertz, or 40 megahertz, or 80 megahertz bandwidth? So you can do a manual channel bandwidth, or you can select something called best. We will be able to do it automatically for your network. But I would recommend you do it either 20 or 40 megahertz, 80 megahertz bandwidth. I've not seen any deployment. We don't have enough channels. I don't see enough benefits of it. But stay with 40 megahertz for a carpeted office. But if you are doing a high-density deployment, best practice is to stay with 20 megahertz only, because you need a lot more channels. For example, in the keynote area, we didn't enable any bandwidth, 40 megahertz channel. We just enabled only 20 megahertz in the keynote area. But in these areas, I think we have enabled 40 megahertz channels on it, just because so that you have more channels available in a high-density deployment. But again, manually, you can stay with 20, 40, or go with best, and it will select the channel selection for you or the bandwidth needed on your network. So that's all we are doing for the RF portion of it. As far as AP groups, RF profiles. Where are we going with our security and policies? A lot of work is going on security and policies. First of all is profiling and classification. This is something we are constantly doing in all software releases. That means what we are doing is, it's almost like having a small identity service engine inside our controllers so that we can do profiling and do more work along with it. So now we can say that what are the user profiles of the devices? Who is connecting to that device? And what type of device you're using in your network? And depending on that, so a user could be a student or a teacher or an admin in a school environment, and they could be using different types of devices. So depending on the identity and the group they belong to and the device type they are using in their network, with the help of their OUI information, MAC information, and device type, now you can say that I'm going to assign a different VLAN for these devices. I'm going to associate them with a different ACL, session timeout, QoS, and time of day, saying that in a school, if it's a student and he or she brings an iPad, I'm going to allow her to stay or him to stay into the network from 9 to 5 in the evening. After that, it will not be allowed in the network at all. So all of these classifications you can do on these devices now. Again, why are we talking about all of this? The idea is moving forward. Ideally, you should have only 3 SSIDs. One for your 802.1x authentication, one for your guest, and the third one for your PSK. And I'll get to that in 2 minutes. So now, with the 8.7 code, there are about 234 pre-existing profiles so that you can natively decide in the controller itself what type of device you are included. It could be an Android device, or it could be an iOS device, and what all software versions we are running on it. It's very easy to, so we look at the DHCP packets coming from the devices. With that, you get some of the information of what type of device it is, as well as we look at the HTTP packets coming from your device. So if it's a mobile device, it has a different HTTP header. If it's a laptop and all, it has a different HTTP header. We looked at it and can use it for your classification purposes. And once you can classify the device, you can associate them to multiple profiles. Next thing, we have been constantly improving and adding on to our controllers is application visibility and control. So what we have done is we have taken the NBAR engine, which is available on our routers, and we have put it into our controllers as well as access points. As a result, now you can just go in and enable AVC, or application visibility, and you will be able to detect more than 1,300 applications natively in the controller itself. So you will be able to say, for example, take a Jabber call and split it into if it's a Jabber audio, video, or a control traffic. If it's a Microsoft Link call, you will be able to find out what type of Microsoft Link call it is. So these are all profiles which are added on the controller itself. So as a result, you can say that what type of device you are using, who is using in your network, and then you can control what type of devices or what type of applications you want to allow in your network. So for example, you have one single SSID called Classroom, which is enabled with 802.1x, with WPA2. A teacher is connected to the network. A student is connected to the same network. Now you can say that you will send a different profile to the controller called teacher, and you say that she's allowed to use all applications in your network, but the student over here is not allowed to do any Skype and BitTorrent in the network. But the idea is they're connected to the same network depending on the AAA profile and the Cisco AV pair, which we are saying, which could be a student or to a teacher. You can now apply a different AVC profile on your controllers. And believe me, this is being done with many, many customers already now. Because in your Active Directory, you have a different group of users called student, you have a different group of users called teachers, and each of them can be associated with a different Cisco AV pair. And once that Cisco AV pair comes back to your controller, now you can say, if it's a student, I'll apply a different profile. If it's a teacher, I'll apply a different profile. And within that profile, you can say that I'm going to do this type of AVC applications or other applications also in your network. Controllers are now integrated with OpenDNS umbrella. So what you can do, the use case behind that is you can detect now what is going on in your network in terms of malware activities, etc. So what we have done on the controllers is every time you connect to the network and you try to browse to, say, www.something.com, we send the DNS query from your client device from the controller to the cloud umbrella system which we have. And then we look into your profile, so we know who is sending that information and where you're trying to go. And we will analyze that information on the cloud platform, on Umbrella, or in OpenDNS, and say that, are you trying to go to a correct site, or your machine is infected, and somehow some of the applications is trying to go to a malware site, etc. So we will be able to look at your URL or to your DNS query and classify it and saying that is it a good query or if it's trying to go to a wrong place. So it will basically, all the DNS requests is snooped, and a copy of it is sent to the cloud. We match through the compliance which your company has created. For example, they are not allowing any clients, for example, to go to any gambling site, just for an example. And then we look for the DNS response. If the DNS response is proper, we let the traffic go through this approved content. But if the DNS response is blocked, in that case, we send a response back to your client saying that your response has been blocked because you are trying to go to a site which is not approved in this case. So all we are doing is we are intercepting your DHCP packet, and we are sending a copy of that packet to OpenDNS, matching up with what is your company profile and your client profile, and reply back to the DNS query either with a positive one or a fail, and redirect the client in case of a failure. So this integration is done from the controller directly with OpenDNS. As long as your controller can reach to an OpenDNS or Umbrella server in the cloud, we will be able to send all the packets and do it a live interaction. A lot of customers have started looking into this, and I'll share the use case in a couple of slides behind that also. There was a question.
Yes, my question. We use Umbrella, but the clients get Umbrella DNS. What does the controller now extra? Because when they go to one side or we have a policy on it, they don't get an answer or the wrong answer. So what does the controller extra between it?
So so when they have an integration with Umbrella, when the controller or the OpenDNS sends an information back saying that all the controller does is redirects your configuration or your browser connection to this website, which you can also configure and say that your connection, some message banner saying that your controller, your company does not allow you to go to gambling sites, for example, or we have detected a malware. All the controller is detecting is if it doesn't get a DNS response or a DNS response back to the right server, it redirects the client connection to a web page which can be hosted on OpenDNS itself, saying that your connection has been stopped. That's all it is doing. No, we don't give that information. No, it's just the DNS packets. That's it. Yep. Switching gears on the security side, if you have not seen this, we added the support for identity PSK on 8.5 software release. As and when the devices are coming into your network, I have seen customers creating multiple SSIDs for their medical devices. They have created SSIDs for their HVAC systems, et cetera, on their network, which is impossible to manage as your network is growing. So what we are recommending moving forward is create one SSID, enable PSK on it, enable MAC filtering, and enable AAA override, and group your devices. For example, all your IoT devices, all your sensors, and if you have your employees, could be of a default group on it. And what we are saying is all your IoT devices to use a single PSK key, for example, AA, BB, and CC. For all your devices which is connected to your network, as soon as they come in, we authenticate and we send it to any Radius server. The Radius server responds back with this PSK key, and you're connected to it. If you have sensors in your network, configure all your sensors to use a PSK key of XXYYZZ in this case. And as they connect it, we send that Cisco AV pair back to the access point, and so that they can now get connected to the network using those information only. But if you have certain devices which your employees are bringing in and they are not registered in your Radius server, what they will be doing, they'll check in, so there is no PSK attributes configured. What we are going to use is the default PSK key on that SSID which was configured. So what we are doing over here is one single SSID, but depending on the devices which you have, and if those devices are registered in your Radius server, we're assigning different PSK keys for those registered devices. But if that device is not registered, they're using the default PSK key on it. But the devices which are registered, they have their own PSK keys. So as a result, now if you say that I lost one of these devices, and which could be a sensor, somebody walked away with it, you don't have to reconfigure your network completely. Only you have to touch your sensors and change the PSK key for those. But for your other IoT devices, you can leave it as it is because they have their own PSK key. But only problem with this, or not the problem, the thing you have to take care of it is you have to register those devices in your Radius server. If you register those devices, that means the MAC address of those devices, you can associate them with their own PSK key. But if you do not have a one-to-one registration, they can still connect to your network over here and use the default PSK key, which is configured on that SSID. So this will, moving forward, help you in reducing those number of SSIDs in your network. Now I have seen many, many customers around the world having 5, 6 SSIDs broadcasting in your network. That's not good. So what I'm recommending is, moving forward, we should go to 3 SSIDs. One for your 802.1x, one for your guest, and one for your PSK key using this over here. What I talked about is identity PSK. All you have to do is, and we made some enhancements on this. This is introduced in 8.5 code, but in 8.8, now we have had enhancements where you can say that you will be only able to communicate between these devices only. You will be able to communicate between sensors only. You will not be able to communicate outside the group also. So we have added those functionalities on it so that now you can say that for your IoT devices, you have real close segmentation. Remember, we heard about a lot of these incidents which happened. Some hack happened through some IoT devices or through some HVAC systems, et cetera, because through those devices, they could access the full network. Now you can do this real segmentation where you can say that it's only among these IoT devices they can communicate. They will not be able to communicate to. So we will be able to send some additional information from the Radius server back over here to your controller saying that this device, which is belonging to one IoT group, is trying to communicate to a device which is part of a different group. We will not allow that. We will drop the traffic on the access points or on the controller, depending on if they're on the same AP or they're on 2 different access points also in the network. That enhancement is added in 8.8, but basic identity PSK is added in 8.5. So take a look at it. The deployment guides are all updated. This is where I think the industry is moving towards. Question at the back. Sorry, I'll come back to you. Yeah. So the question is this possible to enable peer-to-peer blocking in identity PSK? That's exactly what we are doing. We are using. Yes, that's possible. Yes, absolutely. But at the back end, when you enable that functionality, it's actually the peer-to-peer blocking, but we are sending the information from the Radius server itself. Okay? There was a question, another question over there. Yeah. If you're using VoIP on the SSIDs also, still I would recommend using one SSID enabled with 802.1x, because most of the voice devices is going to, and enable protocols like 802.11r, K, and V. Most of the devices are supporting this, including iOS and Android devices. As a result, you can have smooth roaming between your networks. So if you, I think there is a session on Thursday or Friday morning, I think, on how to enable these devices on a wireless network, how to, Jerome Henry and my team is going to do that. I would highly recommend doing that. But again, the message is simple. You don't want to create separate SSIDs for data, separate with voice. You have one SSIDs, enable those protocols of 11R, K, and V, which is now pretty much a standard in every devices, and help you in better roaming. All right, question? Is there any limitation? No, not that I know of. You can have, if you have 6,000 clients connected to it, all 6,000 clients can have their own PSK key on it. So there's no, it's just the amount of MAC address which is supported on the platform, that is the limitation. So if you have 3,000 clients, all 3,000 can have their own PSK keys also. And the exchange is very little, so I don't expect any kind of performance hit on it. So there's no limitation. Every client can have their own PSK key if you want to. Question?
What is the roadmap for the VPA3 support?
For which support?
VPA3.
WPA3. OK. So what is the roadmap for WPA3 support? Very good question. So WPA3 support is coming as part of 8.10 software release. And keep in mind, we are not going to support that on the Wave 1 APs. WPA3 will be only supported on Wave 2 and above access points. But it is coming as part of 8.10 software release, and on 9800 as part of 16.11. So 16.11 on iOS and 8.10 on AirOS, where we will support for WPA3, which is the next upcoming standards. We do have some devices which is available right now. If you want to see the demo of it, if you go to the Whisper Suites, if you're registered as part of the Whisper Suites, I have some devices. I cannot tell who has given it to me, but I have devices which support WPA3, and I can show you a demo of WPA3, which is the next upcoming protocol. So we'll cover those in detail when we come back, but that's what the plan. Glad you asked it. There was another question somewhere here. Yep.
Is it possible to different PSK for every
Is it possible to do it, have a PSK key for access point group? Currently, no. That's something we are looking into it in the future, saying that if you have a remote deployment or branch office deployment and have a different PSK key for that group. Currently not, something we are looking into it in the future, but currently no. Okay? Any other questions? Okay. Yep. Very good question. So the question is, can you do AAA override, a VLAN, etc., using PSK? The answer is yes. Why? Because this is a radius transaction. So we are, even though we are using PSK, it's a radius transaction. So as a result, you can send any attributes back from the radius server, including VLAN, QoS, ACL, and apply them. And I have a slide for that, literally at the end. So summarizing it, so you have a single SSID again, and you have employees connected to it, contractors connected to it, and now you can associate them with different roles. So you can say that all of those devices which are part of sales and marketing will be associated with a VLAN 10. If they are part of a contractor role, they will be associated with a VLAN ID of 20. Simple segregation. But again, keep in mind, all are coming on the same SSID. Now you can take it to the next level and say that I'm going to apply them with different AVC policy, saying that for contractors, I'm going to drop their YouTube traffic, for example. Okay? Then you can take it to the next level and say that I want to control what type of Apple devices they can use in the network. Can they go to the printers? Can they go do Bonjour services for Apple TV, etc.? You can do all that with associating them with the profiles what you have. Then you can associate them with an umbrella policy, saying that, OK, I'm going to block eBay for everybody. They're in office. They should not be looking at eBay. You can try to block Facebook, but there'll be a different issue with that. But anyway, so you can block eBay. For contractors, I'm going to block Facebook also, for example. OK? So you can have that segregation, and you can drop the traffic accordingly for those devices. And the final segregation, what you can do is apply them with separate TrustSec SGT policies also. So now you can say that between those devices, can they talk to each other or not? So if they are having an SGT policy of 4 and 5, for example, which is coming back from your ICE server, you can say it's per permit. That means they can go to the backend servers. But if they get a SGT policy of 5, we apply a SGACL saying that they cannot go to these servers at all. They will be always allowed to go to your default gateway, and that's it. But again, the idea is all of them is connecting to the single SSID of the enterprise over there. It could be a contractor, it could be an engineer, it could be a marketing person, but all of them is on the same SSIDs, but depending on the user profile or the user group, we are assigning separate VLAN, we are applying separate application policies, we are applying what devices they can access, and umbrella policies. So this is where I'm seeing the industry moving towards with the help of one SSID for all your multiple user types on it. And the good part is this can be done exactly with PSK key, as you asked about. So as a result, now, even though they are using PSK keys, you can tell them that these are all IoT devices, these are all your employees. IoT devices will just go out to the internet, for example, or to one particular server, but your employees can go to everywhere in the network extra. OK? So that's absolutely possible on your network. Switching gears, that's all what we are doing for security. Keep in mind, but I'm glad you brought up the WPA3. We will include all the WPA3 moving forward, but that's coming in the future also. IPv6, no changes. We have been supporting IPv6 from 8.0. So we will be able to support IPv6 both for our controllers, as for our clients, as well as on our access points. So we will have support for management interface supporting IPv6. So you will be able to manage the controllers using IPv6. You can configure your network in such a way between the AP and the controller. You can either use IPv4 or you can use IPv6. So you will be able to support CAPWAP over IPv6 or CAPWAP over IPv4 if you want to. I know a few customers who has already moved to IPv6, and they're using everywhere IPv6 for their connectivity, especially in Europe. HA also is fully supported. So you can say the first controller is using IPv4, IPv6, and the second controller is using IPv4, and the third controller. So you will be able to send the CAPWAP queries or the join queries over IPv6 also. So you can have multiple controllers running multiple different types of stack. You can have an IPv6 guest access also. So if you have IP guest access enabled on it, and you are having devices which are only supporting IPv6, you will be able to do the web authentication using IPv6 in your network also. With IPv6, it comes with IPv6 security. We do have support for all IPv6 security. For example, router advertisement guard, RA guard on it. We have support for source guard on it, as well as we have support for all DHCP checking in case if there is any kind of attacks in your network. So natively, we have implemented all IPv6 security functionalities on the controller itself. So we have taken advantage of all the iOS codes which we have. With that, we can take care of all those IPv6 information. Question at the back. That's correct. That's correct. So for application visibility and control, if they are using IPv6, we do not have support for that. We're looking into it. Probably in future releases, I'm trying to get it in, but only for devices which are using IPv6 only. We do not have support for AVC, but that's top of the priority list. Hopefully, probably another 6 months from now, we probably will be able to get that support. It's a matter of changing the engine on the controller to support that. So because the engine is all dependent on NBAR engine, which we run on so it's a different engine which runs. So it's a matter of time that we catch up with it. But its topmost priority now is to support AVC for IPv6. Plus the AP support. Correct. Wave 1, oh, yes, that's also Wave 1 with SD, because if you know about this underlying software on the APs, between Wave 1 and Wave 2, we have changed the complete OS on the underlying. We used iOS on the Wave 1 APs, and in Wave 2 APs, we moved to a new OS called Cheetah OS internally, or COS. The OS is completely different. So there is no plans to bring that on Wave 1 APs, because that is a 10-year-old code. We moved to the new code with the Wave 2 APs, where we have supporting the VXLAN and SDA deployment, and there is no plans to bring those back on the Wave 1 APs. Wave 1 APs was added on the last moment to support the deployments so that you don't have to upgrade your infrastructure, but there's no plans to bring it on the Wave 1. We're very clear about it. Yes, it's a final statement, yes, and you can take my name on it. Branch office deployment, just because I told you the reason, it's the different software versions, and that software is almost 10 years old. And moving forward, that's the reason we moved to the new software versions, which is on the Wave 2s, and that's why we moved to it. Because it's a multi-core software, where multi-threaded, multi-core software. Because if you look into it, the Wave 2 APs, each of those APs have a 20-core CPU on it. Each AP has a 20-core CPU on it, and we have 3 of those on the 4800 APs, okay? You wonder why those APs are heavy. Because of that reason. They have 3 CPUs on it with 20 cores on it, and they need a lot of power, and they dissipate a lot of heat. We have to build those boards to dissipate those heat. That's the reason those APs are heavy and big, because they are not doing only, it's a computer. It's a high-end computer, each of those APs. So I always have a joke saying that one day it will support BGP on it, and I'm going to retire that day. Anyway, so now what we have over here is for the branch office deployment. I'm not going to go through this in detail, but a lot of improvements. So you have the option of putting a 3504 controller for your branch. You have the option of putting a Mobility Express also for your branch deployment, as I talked about. Or the other option which you have is using Flex Connect. That means you have a centralized controller, But at the same time, you will be able to connect all your client devices and send your traffic either locally, drop your traffic locally, or send all your traffic to the centralized location. So this is also very popular. Almost 30% of my customer deployments around the world is using Flex Connect mode, especially in where you have lots of branch offices and you don't want to put a controller in it. You can just connect the APs over the internet or over your WAN link and connect it to the central location on it. The APs can work on what we call as the standalone mode. That means if you lose your WAN connection, your APs will still keep on performing. And if there is an SSID, which is using a PSK key, it will be available and it will be still broadcasting, so you will be able to. And it has two important functions of local switching and central switching. That means you can drop the traffic locally on the AP, or you can send the traffic all the way back to your central controller on it. Some guidelines, this is very important. This is how we are still doing the testing. We say that if you have a site with 5 APs, 25 clients, and you have data and voice deployment on it, you need minimum bandwidth of 75 kbps and 300 milliseconds of round trip between your controller and access point. But if you're doing a voice deployment, I would recommend that you should have a latency not more than 100 milliseconds. That's what I would recommend in case of a voice deployment over Flex. But if you're doing only a data deployment, you can go all the way up to 300 milliseconds of latency on it. Okay? So I talked a lot of stuff. We talked about AP groups. We talked about RF groups. We talked about various tuning of it. One day, I sat down with a couple of my TAC engineers and escalation engineers, probably heard about Javier and a couple of other folks, and I wrote down in a piece of paper, and I made this slide, what are the best practices we recommended? What sort of best practices we should follow, because there are so many. So then I said, this is painful to go and check all of this in your implementation. So what we have done moving forward is some of these best practices will be enabled by default as recommended by TAC and escalation in the controller itself. So as you upgrade your controllers from 8.1 to 8.3 to 8.5, 8.8, as we are learning over a period of time, we are enabling certain best practices in your controller itself. So we know that band select is working fine. We have used it for a while. And if TAC is recommending that, we are going to enable. So there are about 30 or 40 best practices which we started with all the way with 8.1 code. But moving forward, we are adding more best practices. We work with Apple, for example, to create those best practices. And we created a deployment guide based on, say, 8.6 software code, and we added that onto the documents. But what I have done with engineering is implement those best practices on the controller itself. So you will see a section which says, what are the Apple devices, if you have, what are the best practices you need to follow? So as a result, what you will see over here that we look into your configuration and come up with a recommendation saying that looks like you're following only 50% of the best practices which we recommend. These are the suggested configurations you can tweak in order to follow through your best practices, what is recommended by Cisco and Apple joint testing. And we do this for every release, every major release, like 8.5, 8.8, etc. on it. So take a look at it. There are lots of Cisco devices where we talk about best practices. This is the only device I can think of where the best practices is built into the controller itself, into the device, and you will be able to audit in your device and say that what type of. So this is located in a section called monitoring and best practices. It not only does the best practice of this thing for Apple devices, but it does about 100+ checks in your network. 100+ configuration checks in your network to tell you where you are as per the recommended best practices. And if you don't like some of them, you can disable it and say, I'm going to ignore this because this is not suitable for my environment, and leave it as it is. Okay? So that's where it goes to the delete. If you do the detailed information, it tells you all the details information. If you want to ignore that best practices, you can always ignore those best practices on it. But if you don't want to do that in your controller, I don't know if you have seen this. This is a config analyzer available on cisco.com, where you can take the configuration of your controller and put it onto this analyzer, and it will go through more than 200 best practices recommendation and tell you exactly what is going on in your network. If you are facing any issues, this is what TAC does every day. TAC maintains this database to make sure that you put in your configuration over there and comes up with this messages saying that what are the kind of issues in your network you are seeing, and you will be able to recommend what are some of the best practices which you may be missing on your network looking at the configurations over there. So if you have open TAC cases right now, you can always send them the configuration, or you can go to this site which I have and put in your configuration. You will be able to give you the detailed analysis on it and tell you that what could be. You might have missed some configuration. We might have missed some configuration. You will be able to do those analysis directly on the controller itself. So I think that's all I have as for my presentation. HA pretty much becoming mandatory. Take a look at all the functionalities we added with AP groups, Flex Connect groups, as well as IRCM. We are spending a lot of time on IRCM so that you can roam between one controller, multiple controllers, including the 9800 series controller. And finally, a lot of focus is on Prime, ICE, Umbrella, and DNSE. That's where we are spending our time. We are spending a lot of time on netconf and YANG models. We are spending a lot of time to do that telemetry and send those information to DNSE, so that to help you in troubleshooting. My next year is completely focused on how can I get more data from the controller to build those troubleshooting tools and build those systems which we are calling about artificial intelligence, machine learning, etc. So that we can now detect before the problem happens. Meaning, if we are seeing that every day at 12 o'clock, your network is going down because there is microwave ovens which are getting enabled on your network because of lunchtime, how can we reconfigure those APs in order to change channels at 11:30 itself so that your network is not behaving badly? So how we can get those machine learning information and get those data back to the controllers so that we can perform. So that's where we are going towards, how we can enable telemetry on your controllers to get those data to DNS center and ultimately to enable machine learning and artificial intelligence so that we can automate some portions of your network. You don't have to go and manually go into it. Okay? So that's all I have. Enjoy the rest of the show, and I'll see you around. Okay?